Osbert, are you there?
Yeah, I'm here. Let's see, where is it?
Okay.
Screen mode. Window, right? Yeah, we can do window. Let's do it that way. So, okay. So,
All right, Osbert,
this is,
I can hear and see you. You're good to go.
All right, so this is a sort of a brief look at indirect seasonal adjustment using multivariate signal extraction versus existing methods. And by existing methods, we're kind of focusing primarily on the capabilities built within the X13 software. This is work with James Livesey and Colt Beerdorfer, both also of the U.S. Census Bureau. Why is this not advancing? There it goes. The usual disclaimer applies. So, this is sort of a generic introduction. We have a time series. Typically, we decompose it as, the series we decompose into broadly a trend, cycle component, a seasonal component, and an irregular component. And sometimes the trend cycle component can be further split into, a separate trend component and a sort of separate cycle component. Seasonal adjustment, we're familiar with this. It's sort of the process of estimating and removing seasonal effects from time series for the purpose of, revealing certain non-seasonal features that may be obfuscated by the seasonality in the series. So the seasonal adjustment, the composition estimate sort of is just our series minus the estimated seasonal, or alternatively, it's an estimate on the trend plus the irregular. So how does this change slightly when we talk about this in a multivariate sense? Well, in general, instead of these are now, so now our X, T, S, and I are potentially multidimensional. The series may have multiple dimensions. A potential benefit to this is accounting for cross relationships between series. The obvious downside to this is that we sort of increase the complexity of the resulting model. In the sense, we have more parameters to estimate now that we end up increasing the dimensionality. Sort of an example of, so this is one example. We have automobile manufacturing, and the green line represents a value of shipment series, and the red line represents total inventories. So, this is two different measurements on sort of the same industry, if you will. And that's one potential way you can get correlation. This is one way you can have cross relationships between series. And then an alternative, a second way you might get cross relationship is we have, in this example, we have total consumer goods, and we're looking strictly at the value of shipments. And here we have, the green dashed line are consumer non-durable goods, and the red line down here are consumer durables. And in this case, what we have are, two series that are not necessarily the same industry. They measure the same thing, and they sort of naturally aggregate up to a sort of a larger series. So, this is sort of a conjecture, if you will, on what, multivariate seasonal adjustment could be in practice. So, the pie in the sky would be that we sort of adjust a related series jointly, and we release each of these individually. This is sort of, not something that we would expect to see in the near future. I mean, part of it is also that, univariate automatic modeling is already sort of in a fairly, is in a mature state, and it works fast. What we would need is sort of substantial improvement in computational speeds for this to sort of be a more feasible option. So at least the way I sort of see it, maybe, is that, the way is more sort of custom aggregates for both individual release and indirect release, in the sense that we're looking at this almost retroactively. We can sort of use this to, compare to what's out, to what does get released, to see, are there any sort of, it's sort of used as a check almost. And we'll look at some facets of this. So this is sort of an example of what might happen in an ideal simulated scenario. That is, we take a series, a simulated series, or a bunch of simulated series rather. We sort of, we adjust, we do a couple of univariate adjustments using seats in this particular case. We aggregate them up, and then we sort of repeat the same, but we do it as a bivariate fit using a multivariate setting, labels or such. And the idea is that, it's possible, at least in an ideal simulated scenario, that you can do better using a bivariate fit on a series as opposed to a univariate fit, or a couple of univariate fits and then aggregating. The data that we're sort of looking at for this particular case study, for this particular thing, this is sort of a partial list of categories and sort of subcategories from a particular census survey. The manufacturers, inventories, and so on the left we have the sort of aggregate, the sort of category series, and then on the right hand side, we have their sort of natural disaggregates. So 12S is beverage and tobacco products, which is split into 12A, which beverages, and 12B, tobacco products. Consumer goods over here gets split into durables and non-durables. Computers and related products here can be sort of obtained by summing computers, storage devices, and terminals and other peripherals, and so on and forth. We won't delve. There are more than just this, but this is sort of the data structure that we're sort of thinking about. So at least for our approach, what we're considering is, we pick an aggregate, and then for each of this sort of, I guess we'll call them the disaggregate series or the component series, we perform a univariate seasonal adjustment. We'll look at it from both an X11 and the seats perspective, and then we will sort of repeat this, and then we use using the HA Signum package in R. We'll sort of do this as a multivariate adjustment instead. Looking at this sort of in two different ways. One is, say, if we group by the quantity being measured, that is, we sort of adjust, we've sort of modeled the, a bunch of value of shipment series together. And then, the quantity being measured, my bad. The quantity being measured, we group by, their all value of shipment series. We'll sort of group them this way. And the second way, we group by disaggregate. That is, we group, multiple series that are measuring some facet of beverage manufacturing, for example. We obtained the indirect adjustments by aggregating the resulting estimates of trend and seasonal adjustment, and we'll sort of just compare results. So, so this is sort of a quick illustration of what we mean by these sort of two different grouping ideas. So this is the motor vehicle and parts series, and we have here 36A, which our call is automobiles. Well, let me just make sure. Yeah, automobiles. 36B are light trucks and utility vehicles. 36C are heavy trucks, and BTP are something like trailer parts, etc. But regardless, the natural aggregation relationship from this is sort of a natural aggregation relationship for motor vehicles and parts. And, so we can see that, there are a couple ways we can group this from multivariate. One option is we group along this way. This is sort of what we mean by grouping by series type. We group we sort of fit the value of shipment series together. And the benefit of this, if you will, is that, when we fit this one model, we can sort of get we can get the indirect adjustment immediately. That's, which is, it sounds nice. The alternate, the other way we might consider grouping this is we end up grouping by, the industry. In this case, we group by the, in the one I'm highlighting, we're grouping, automobiles, and modeling, value of shipments and total inventories together at the same time. And this is, in one way, we might argue that these two, that grouping it this way may yield series that have, that may be more strongly related. And at least, in this particular sort of illustration, this may also be a more manageable fit, in the sense that instead of doing, instead of doing, to get these two, if we did it the other way, we'd need to do, say, two different four-dimensional fits. And in this way, we're sort of considering it as sort of four two-dimensional fits. The drawback to this is, is that you sort of need to run, you don't really get that, in the other way, you get the natural aggregate immediately once, you get a natural aggregate once, you get one fit done, it gives you the indirect adjustments. This particular setup would sort of force you to, force is maybe wrong, but basically only, you only obtain the indirect adjustments once you have actually done all four for both of these. But, like I said, this may be a more manageable structure. So we did this for all of these, and, I'll sort of just highlight a couple of examples. So in this case, we're looking at a differencing operator of some sort, delta B. In this case, we will just take the first difference, and we're looking at the standard deviation of the differences divided by sort of the average, the absolute value of the average difference as an approximate measure of smooth, as sort of approximately measures this. We did this. So, So here we have series that we sort of, for univariate settings, we sort of modeled this as airline models, and for multivariately, we sort of tried to reproduce an airline model in a sort of component specification, or something similar to an airline model. And in this case, and then for these batches, the AMD ones, we sort of look at it as, well, instead of forcing an airline model, we sort of fit a we allow AutoModel to pick what is probably the better model, what it considers to be a good model, and then we sort of, and then for the bivariate settings, or multivariate settings, we try to make a component specification that kind of nests the overall the models that would be going in. And in general, in this case, for the indirect seasonal adjustments, what we're sort of seeing is, at least for total inventories, these are pretty there's not a huge amount of difference. For 12S, it looks like, if you force an airline model, that it's a little smoother if we're doing it as a bivariate fit. If we're doing it, with AutoModel, it looks like
sort of listening, but I'm also at a meeting. And they're making it.
If you're in the room, could you please mute?
Already,
I will do my best to scour and see if I can find the culprit and mute them.
Well,
You can continue.
and then oh yeah, sorry about that. Yeah, and then on for the auto model though, it looks like a seats indirect adjustment is generally smoother compared to the others. Similarly here though, for value shipments, if we do force an airline model, it looks like our for value shipments at least 31S, which is I think aluminum metal products. It's a little smoother to look at the indirect adjustment of the seasonal adjustment, at least by this particular measure being calculated. On the other hand, for trends, there really isn't. I mean, over here on this sort of reverse there's this sort of distinction sort of goes away here. We sort of see it's more or less, they're fairly comparable outside of this grouping, which is grouping by industry. And over here, they're pretty similar. Here, it's a little smoother to do it bivariately, and similarly here, it's a little smoother to do it bivariately, or smoother, perhaps in quotation marks. Are there any issues with the indirect adjustment in terms of, does there appear to be residual seasonality? And at least, the way when we looked at it, it seems like these all, like I said, values above 6 we would consider worrisome. So at least for these particular examples being shown here, it doesn't really look like we've got any serious, what is this? Yeah, it doesn't look like we have any serious issues arising, at least in this particular series, regardless of how the fit has been obtained. This we're looking at is, well, I'll skip over. I'll sort of list these specifically. This is looking at, okay, so what we do here is for the last, we sort of take the last year of data. We sort of, we sort of chop off the last year of data. We then, proceed to successively add a month to this series with the sort of fit. And then we sort of see how much the terminal point of the series changes. Yeah, how much the estimates of terminal point of the series changes as we introduce an additional data point, each successive terminal point. Over here, in terms of the absolute percent change we sort of see that grouping by industry, at least for beverage and tobacco products, seems to be, the revisions tend to be a little larger overall, I'd say, if fitting bivariately compared to doing an indirect adjustment using, a bunch of univariate approaches. And similarly for trends, well, on the whole, I would probably argue that, again, a multivariate fit seems to result in slightly larger revisions to the indirect trend estimate as well. So this is sort of just a visual comparison of an indirect seasonal adjustment, and then we've sort of restricted the time frame to just the last 6 years or so of the data. So and we sort of try to keep the number of lines a minute. So, the sort of purple line that I'm sort of following here, that's the original, that's the actual non-seasonally adjusted aggregate series, primary metals, value of shipments. And here we have, the lines corresponding to the indirect seasonal adjustment done a couple of ways. So the reddish line is when we group by industry. In this case, this is a trivariate. So this is basically grouping. This is 3 bivariate fits and we're sort of summing them up that way. Grouping by type is when we do one trivariate fit of the value of three value of shipments components, and seasonal and seats is basically just 3 univariate fits. And these track, for the most part, they track reasonably well. I mean, we sort of see here that the indirect seasonal adjustment done univariately seems to have peak here compared to the other two. This one, the grouping by the industry setup, seems to round off the edges a bit over here, and it might overshoot it, and it seems to be a little more jagged over here. But by and large, they're similar, which is not a bad thing, I guess. On the other hand, this is sort of we're looking at indirect trend. This is again primary metals, total inventory. In this case, we're looking at again, so again, the purple line is the actual trend, or is the actual series for total inventories rather, not seasonally adjusted. And what we see now is that although that the indirect trend estimate, when we group by the industry type, and the univariate and the indirect trend estimate when we fit a bunch of univariate fits, these two seem to track, reasonably closely. I mean, one is a little more smooth than the other, but when we do the one, trivariate fit, well, this one seems to be not quite on the mark. It seems to be a little, the time. It seems to it's diverging from the movements of the other ones. It seems more so. So considerations. Well, one thing we sort of grappled with a bit is what we should consider the right multivariate fit. A second limitation, another limitation, if you will, is that we sort of avoided adding outliers to this, which does lead to which does mean that certain things may end up missing a bit. Overall, what we're noticing is that indirect adjustments can be slightly smoother if we use multivariate fits, but that it may also yield slightly larger revisions, at least the way we're doing. There are some, there as a whole, it doesn't really look like there's a huge difference between grouping by the two different ways we might consider doing our multivariate fits group wise. But speed is sort of the eternal issue, I guess, is how I would put it. It's I mean, the comparison is, I mean, if we fit this sort of trivariate, this sort of setup, for example, doing it in X11 with X11 or seats, we would get the 3 seasonal adjustments for this in about, I don't know, maybe a couple seconds at worst. Maybe a little slower if we invoke the composite spec for this. But it's pretty fast. Doing it as sort of 3 bivariate fits, well, each bivariate fit can do maybe, a few minutes, can go. My impression is, I don't know, somewhere between 5 and 20 minutes. I've had it. One 3-dimensional fit can be, I don't know, 30 to 50. I mean, it doesn't get any faster as you add more dimensions. So like I said, speed is sort of the big issue, I guess, with this. So yeah, and we're still sort of working our way through this as well. So there's still things to explore, and I believe that is. Oh, okay. And here's a brief list of a partial list of some references. Perhaps the important one here is this thing, which is you know, where we the ARP, which is the code for where we did a bunch of this analysis. And I believe that's all. Yeah.
All right, thank you very much. Osbert, are there any questions?
Stop sharing. That's the button. Sorry.
If there are no questions, then